Let's look at the solution of algebra bytes. How many integer pairs xy satisfy under root x plus under root y is equal to under root of 2 times of under root 64? This RHS under root 64 is 8. So I have under root of 2 into 8, which is as good as under root of 16, which is as good as 4 itself. So I need under root x plus under root y to add up to 4, and I need integer pairs of x and y. So I can see that x and y cannot be negative because then they would turn into unreal numbers. They have to be whole numbers only. So the first case I can see is 0 and 16. Under root 0 is 0, under root 16 is 4. Summation works. Then I can have 1 and 9. Under root 1 is 1, under root 9 is 3. Then I can have 4 and 4. Under root 4 is 2, under root 4 is 2. Then I have 9 and 1. And finally, I have 16 and 0. So I get 5 cases in total. Answer to the question is 5. Next, for how many integer values of x does the inequality, this inequality hold true? Okay. Now this is mod term inside and then modded outside. So we have to draw two graphs. First, draw simple x minus 1 mod graph. Just for this much portion, draw a graph. It would be at x coordinate equal to 1. The root of this expression is going to be 1. Okay, this we have got. Now from this expression, from this graph, you're subtracting 2. Effectively, whatever v shape you're getting, you're pushing it down by 2. If we are pushing it down by 2, we end up with this. Here, the value of the function was 0. Here, the value of the function is going to be minus 2. But then this is not the final graph because this broken down line function is again getting modded. So the final function that we'll be working with will be something like this, a W getting created. At x equal to 1, the value of the function would be 2. Now from 2, if I have to come down to 0 in steps of 1, because the slope of the function in any part of this, the slope will either be 1 or minus 1. From 2, if I have to come down to 0, I have to take 2 steps rightwards. So this will be 3. From 2, I have to come down to 0. I have to take 2 steps leftwards. So from 1, if I take 2 steps leftwards, this is going to turn to minus 1. And now I need this function to be less than 5. Okay. If it is less than 5, let's say this is y equal to 5 line. Then from 0, I have to go to 5. I will take 5 steps rightwards. So this here would be at x, value of x as 8, you would get the value of the function as 5. And then I have to take 5 steps leftwards. So at x equal to minus 6, you will get value of the function as 5. See that the question is not asking for where the value of the function is 5. It is less than 5. So anything within this range would count. So minus 5 to 7, these many numbers I have to count. So 5 negative numbers. I have 1, 0, and I have 7 positive numbers. Altogether, I get 13 potential values of x where this inequality holds true. This is the answer to the question. For how many to hold true? Okay. Next question. If a and b are roots of 7x square minus 6x plus 1 is equal to 0, what is the value of the following series? A plus b plus a square plus b square plus a cube plus b cube, so on and so forth till infinity. Okay. First instinct was, of course, to can I break this down? But when you deal with this expression, you realize middle term splitting wouldn't really work. So that is not ideal. Alternately, if you look at this final expression that we are working with, final expression, the infinite term series that we are working with, look at the alternate terms. This is a plus a square plus a cube and so on. And you have b plus b square plus b cube and so on. These are two infinite GPs. We know sum of infinite GP is given by a by 1 minus r. The r here is also a. So a by 1 minus a. And here we get b by 1 minus b. We have to simply add these two up. So we would get A minus AB plus B minus AB upon 1 minus A minus B plus AB. This is what we will finally end up with. Now, basically, we have A plus B minus 2AB by 1 minus A plus B plus AB. This is what we have. Now, looking at this equation, we know sum of roots. The roots are A and B. Sum of roots A plus B is given by 6 by 7. And product of roots AB is given by 1 by 7. We simply have to plug in those values into this expression. So I have 6 by 7 minus 2 by 7, whole thing divided by 1 minus 6 by 7 plus 1 by 7. Okay. So this gives me 4 by 2, or the final answer that we seek is 2 itself. The answer to the question is 2. Next, A square by 4 plus B square plus C square by 9 is equal to A plus B plus C minus 3.5. Okay, where A, B, C are real numbers, and then we are tasked with finding out the value of this expression. Okay, so the only idea that comes in my head, because there are 3 variables involved and we are expected to find out the value of this expression, the only way this can work is, and the original expression contains a lot of squared terms, the only way this can work it if I can make a perfect square out of this and then take it forward. Let's see, I'm multiplying every term by 36. So I will end up with 9A square plus 36B square plus 4C square minus 36A minus 36B minus 36C plus 36 into 3.5 would be 126, and this will be equal to 0. My intention, my target here is to complete squares. So I'm looking at 9A square and minus 36A. I'm just looking at these two. I know 9A square is whole square of 3A square. So break down this 36A into 2 into 3A into what is the third number that I need? It would be 6. 2 into 3A into 6 will give me minus 36A. So add a 6 square at the end. Add a 6 square at the end, or a 36 at the end, because now this will translate to 3A minus 6 whole square. My life is simple. Next, look at the B terms. 36B square minus 36B. Okay, this is 6B whole square minus 2 into 6B. 12B I've got. So I need an into 3. So at the end, let me add a 3 square or a 9, which is 3 square. This is 6 square. So altogether, if I look at only these terms, I will get 6B minus 3 whole square. Finally, I will do the same thing with C's. I get 4C square minus 36C. 4C square is 2C whole square minus 2 into 2C into 9. Then I get, so I will have to add a 9 square, or then 81 here plus 9 square correspondingly. So effectively what I have here is 2C minus 9 whole square. Now the fun thing is, we had this as constant earlier. We have broken down 126 into 36, 9 and 81. We have broken down 126 into 36, 9 and 81, and it adds up to 126 only. See, sometimes it may not necessarily break down entirely. Some part of it might remain. Then you add that. Because it is breaking down entirely here, this is equal to 0. So look at the final expression that you are dealing with. I don't have space for, maybe I can write it here. 3a minus 6 whole square plus 6b minus 3 whole square plus 2c minus 9 whole square is equal to 0. The only way this is possible is if a was equal to 2, so that this turns to 0, and b was equal to half, so that this turns to 0, and c was equal to 9 by 2, so that this turns to 0. We have our precise values of a, b, c. Let's go ahead and calculate what we need. We need 4 plus 4 into square of 1 by 2 is 1 by 4 plus square of 9 by 2 is 81 by 4. So I have 4 plus 4 into 82 by 4. 4 and 4 cancelled. The final answer that we get is 86. Last question. 89y minus 272x is equal to 28. What is the sum of x and y? Both x and y are natural numbers less than 100. Okay, this is a fun question. Look at this. 89y minus 272x is equal to 28. Yes, fun thing. I'm taking this x term to the other side. 89y is equal to 28 plus 272x plus 272x. So I want to break this number down into parts that I know have to be multiple of 89 and parts that are not. 89 into 3. 89 into 3 is 267x. So can I break this down as 28 plus 5x plus 267x is equal to 89y. This is a multiple of 89. This is a multiple of 89. This also has to be a multiple of 89. 28 plus 5y also has to be a multiple of 89. Now thought process wise, can you see 28 plus 5x will always end with unit digit 3 or 8. These are the only two unit digits possible. These are the only two unit digits possible. So I am working with, see, this x portion is there. Can I say if 28 plus 5x has to be a multiple of 89, 28 plus 5x has to be a multiple of 89, and it can only end in unit digits of 3 or 8, 89k here also has to end with unit digit of 3 or k. Earliest spot where we can get unit digit of 3 or k or 3 or 8 for 89k is of course at k equal to 2. At k equal to 2, RHS will turn to 178 is equal to 28 plus 5x, or x will turn out to be equal to 30. I don't know what happened. Wait, I'll come back. I think it stopped. Okay, so we are back. X will turn out to be equal to 30. If x turns out to be equal to 30, if an acceptable value of x turns out to be equal to 30, because you wanted both x and y to be less than 30. Can you see? If x turns out to be equal to 30, now I have 89y is equal to 28 plus 272 into 30, or 89y, or in fact it is better than this. What I can write it as is eraser, 1 minute. (28) plus 5x plus 267x, which is as good as 3 into 89x. So I know this part turns out to be 188. And this is 3 into 89x, or this is 2 into 89 plus 3 into 89 into x is equal to 89y. I can get rid of 89s from everywhere. The acceptable value of x that we had found was 30. So y will turn out to be 92. And can you see, we found one acceptable value of x, we found one acceptable value of y, we found one acceptable value of x, we found one acceptable value of y, and both of them are less than 100. Given the fact this is a theta question, there will not be any other case. Or even if you want to go down into finding out the next case, 272x is equal to 28. The next case would be, the first case we have identified is 92 and 30. The next case would be 92 plus 272, and here the next case would be 30 plus 89, in which case both of them would be greater than 100. So there are no more cases possible. The answer to the question will be 30 plus 92, or a total of 122. That will be all for this episode. Hopefully you learned something.